Hello students! Previously, we learnt about various concepts related to trigonometry. Let's recall some important concepts that we have already learnt. The word trigonometry is derived from Greek, where trigonon, which means triangle, and metron means to measure. Trigonometry, thus, is simply the branch of mathematics that describes the relationship between angles and sides of any triangle. We know the triangle can be acute, obtuse, or right-angled triangle. However, we will focus on the right-angled triangle only. Thus, we can see that trigonometry for us is simply the mathematical branch that shows relationship between angles and sides of a right-angled triangle. Then what is a right-angled triangle? It is a triangle with at least one angle equal to 90. So the triangle that you see here is a right-angled triangle. Let us name its vertices A, B and C. Yes, these 3 points are where any two sides of triangle intersect and form an angle. They are called as vertices. So can you identify now which angle is 90 here? Yes, you are right. Angle B measures 90. Thus, like all other triangles, it has 3 sides, AB, BC and AC, and 3 angles, angle A, angle B and angle C. Can you identify the hypotenuse here? The side that is opposite to the 90-degree angle is called the hypotenuse. We already know this, isn't it? Yes. Eventually, it is the longest side of all the 3 sides in a given right-angled triangle. Yes, this is always true. In this case, since angle B is 90 degree, the side opposite to it is the hypotenuse. This means AC is the hypotenuse, the longest side of this triangle. Do you remember the 6 trigonometric ratios we found out for these 2 angles in a right-angled triangle? Let us see about sine of given angle. Recall that the sine of any angle is written as the ratio of the opposite side to the hypotenuse. So what are sine C and sine A? For angle C, AB is the opposite side. Therefore, sine of angle C, ratio of opposite to the hypotenuse, that is AB upon AC. Similarly, for angle A, BC is the opposite side. Therefore, sine of angle A will be BC upon AC. Do you remember the cosine? Cosine is the ratio of the adjacent side to the hypotenuse of right-angled triangle. So what are cos of angle C and cos of angle A? Here, for angle C, BC is the adjacent side. Therefore, cos C will be ratio of adjacent upon hypotenuse, that is BC upon AC. Similarly, for angle A, AB is the adjacent side. Therefore, cos of angle A will be ratio of AB upon AC. Now you must be thinking that AC, the hypotenuse, is also adjacent to angle C and angle A. So can we substitute AC instead of BC or AB in the formula? The answer is clear no. Note that here AC cannot become adjacent or opposite to any angle, and that is why we have given this side a separate name, the hypotenuse. It has to be remembered that whenever we refer to the adjacent or opposite side of any angle, we are referring to the sides other than the hypotenuse. Thus, the opposite side is one in front of the angle and the adjacent side is the one next to the angle. Similarly, the tan of any angle, that is, the tangent of any angle, is the ratio of opposite to the adjacent side. Here, for angle C, AB is the opposite side and BC is the adjacent side. Therefore, tan of angle C will be AB upon BC. Similarly, for angle A, BC is the opposite side and AB is the adjacent side. Therefore, tan of angle A will be BC upon AB. So far, what we have seen is the sine, cosine and tangent of these angles, that is angle A, angle C and angle A. What about the other three ratios? Yes, correct. They are cosecant, secant and cotangent. The following three trigonometric ratios are simply the inverse of these three ratios. Cosecant, written as cos, is the inverse of sine. Secant, written as sec, is the inverse of cos. And cotangent, written as cot, is the inverse of tan, that is tangent. You have to remember only these three ratios, that is sine, cos and tan. The other three are just the inverse or reverse of these three ratios. There is one more thing that we learned in the previous chapter. Do you remember this table? What does it show? It gives the values of trigonometric ratios at particular angles. This table shows that if angle A or angle C measures 30, then the value of sine A or sine of C will be 1/2. Or if they measure 45, then the tan of A or tan B will be 1. The value of sec of A or sec C will be √2 and so on. So do we need to remember the whole table? No, of course not. We just need to remember the values of sine. So simply, we remember the value of sine, which is written as 0 to 1 rightwards, and for cos, 0 to 1 leftwards, that is reverse of sine. And tan is simply the respective division of sine upon cos. And these three ratios are simply the reciprocal of their respective three ratios, that is cosec, the reverse or inverse of sec, the sec, reverse or inverse of cosec values, and cot is the reverse of tan values. As you can see, if tan 30 is 1/3, cot 30 is √3, its inverse. If sine 45 is 1/√2, cosec 45 is √2. It is simply the reverse. Now students, knowing all these functions, it's very important to understand and apply them in solving problems of trigonometry. So I hope you'll remember this. We will learn some applications of trigonometry in our coming videos.